Hello everyone and welcome to this brief presentation on the project funded by North East Catchment Management Authority on acidity and erosion. We've taken an approach to present this first part as a soil health component, as a bigger picture farm management issue, and then with a focus on the acidity and erosion throughout the presentation. I'd like to thank North East Catchment Management Authority, Chestnuts Australia, Connexus Global and Trevor Ranford for the cooperation to put this small project together. The idea is to inform growers around the risk of acidity and erosion, and we'll get to that a little bit more in some detail in the second presentation, which will be available as a video through the website. We'll be looking at overall a framework for managing soils as part of the project. We probably won't get to that in great detail, but looking forward to other events that we can all get together again through 2021, and the likelihood is we might need to do a video with some more specific applications for both managing acidity and managing soil erosion. We have taken numerous analysis from two sites. That is one at Stanley on the red soils, and another down in Myrtlefoot on the river flats, quite loamy soil. I'd also like to thank Native Seeds for providing some microlina, which is a native grass from a shaded habitats, and we've got a picture of that small demonstration plot in the second video. And also like to thank RapidFert, a company that has changed its name more recently and providing soil analysis and certainly lime applications throughout the northeast of Victoria. I'd like to thank both of those for their cooperation in this project too. So if we look at soil health, we're looking at soil health being the ability of a soil to keep producing. In the way in which we manage soils in agriculture, we are contributing to constraints that exist in the soils, or we are looking to manage those constraints. If we look at the principal interactions of soil health, what we are really looking at is the relationship of the perspectives biology, chemistry, and physics of a soil. So physics is the texture, sandy, silty, clay, and the combinations, and nutrients are the chemistry. Often we see this diagram presented as chemistry. The relationship of nutrients, we'll touch on that in this presentation, and we'll also touch on that relationship of biology and the role it plays. Each of those relationships of those three perspectives are really where we refer to soil health as the functioning of soil. So there are quite a range of functions that soils provide. These are the four main functions in soils that we concern ourselves with as growers. So it's residue digestion. We want leaf and stem to digest quickly because it provides habitat for many diseases that we get in crops. Nutrient cycling is the availability of nutrients to become available to our plants as they grow for efficient nutrient management. We're not talking there about fertilizer application as such. We're talking about the step on from residue digestion, where leaves and stems, burrs in chestnuts, break down and provide the nutrients that's stored in them for plant use. That's what we're referring to as nutrient cycling. Soil structure and maintenance, pest and disease regulation, they're functions that occur in the soil naturally, and agricultural systems, we do need to understand them so we can manage them better. When those functions occur, we will get results that we see as properties of soils, and here's a number of them. Properties that we would look at favourably for being of value to us as growers. When the soil functions properly, we'll get deep root zone activity with our roots being able to grow through the soil. Favourable soil strength, because the relationship of nutrients and biology is working in a heavy clay soil or a sandy soil to perform as best it can and help us grow crops. This is sort of the interchange between a natural forest system, a natural ecosystem, and a managed agricultural system. So we will often see in magazine articles and newspaper articles a lot of discussion around managing the ecosystem or the agricultural system more like nature. So that's really, they are not the same thing as far as I'm concerned, and we do need to be a bit careful taking those gross assessments or judgments of it. In terms of soil health and soil functioning, pH is probably one of the key drivers of soil performance. It has a role in the textural component of soils. It has a role to play in the biology and the activity of microbiology in the soils, and it certainly has a strong influence on nutrient availability in soils. This is a very important chart, and I would encourage everyone to become more familiar with it. We can see here on the left of screen, and we're talking about acidity in the northeast, so we won't worry about the others above 7 pH. But this pH is a measure of hydrogen. We'll touch on that in a moment. The more hydrogen that becomes available, the more our acidity increases, which is the lower number. As that acidity increases, it makes some nutrients more soluble, like iron, and we can put aluminium in here as well. Iron and aluminium, we'll touch on those in just a moment. So they become more soluble, they become potentially destructive to soil aggregation, certainly damaging to roots, damaging to microbiology activity in a farming and growing system. There are extreme cases where some organisms and some plants will grow in high iron or high aluminium soils or high sulfur soils, but that's not our current agricultural systems and the main crops that we look to grow. We often see a reference of pH at 6 to 6.5, and you can see there that there's a good availability of nutrients at that 6 to 6.5, and that's really where majority of crops are most comfortable that we grow for food production. In terms of aluminium, just as an example, in a cotton root here, we can see that at 6.5, we've got active roots. They're protruding through the soil or working their way through the soil. The more soil that those roots can come in contact with, the more nutrient that is available to them, the more biological activity is available around those roots, and the more water that's available, particularly in Australian agricultural systems, more water that's available that's providing that opportunity for growth in the plant. We can see here at 2 other pHs, a more acidic soil. The cotton roots are particularly restricted. Less moisture availability, less nutrient availability, greater risk because there's probably damage. You can see they're quite active, healthy white roots. And here we can see actually, even though the quality of the image is a little bit poor, we can see damage to the root. That's potentially increases the risk of infection with pathogens. In terms of measuring our soil nutrient levels in soils, and we're going to also look at measures of biology in just a few minutes also. The primary tests that we would do in Australia are exchangeable, and that will provide us with a fairly large amount of nutrient that should become available to the plant as it exchanges through soil functioning with other nutrients and growth and moisture availability. The total extract is the whole pool of soil in an area, so that's all the nutrient that may be available. So that we would look at what we would commonly refer to as a miner's grind. They would grind that, extract as much nutrient out of it if they're looking for minerals or of particular types. Soluble extractions are also available. We'll see some of them are commonly used in a couple of labs and are readily available. Soluble will often be a very, very small amount of nutrient because it's only measuring the nutrient that's available in the water. So while an exchangeable test will be able to extract a fair bit of what we would anticipate to become available to the plant, the only bit that is at any particular point is that's in the soil solution, and that's what that soluble test is. To make that available, biology plays a particular role, and that's where we'll be looking at, again, that soil health component of biology providing that function for us. This is a typical test from a exchangeable type extractant, and we can see there we'd be looking at what are the relationships that are going on, and can we look at some aspects here in this test that would indicate functioning of the soil and any constraints. In this one, probably not. It's a very, very probably a sandy type soil with very low availability of nutrients, typically, and that would be somewhere where in a sandy soil we'd be looking at more frequent applications of nutrient at lower rates, and then also selecting the types of nutrients that we would make application to. In terms of touching on biology and soil health, this is a test of soil. Urundes is a test where growers are planting cotton underwear in soils, but it concerns me, and digging them up 8 weeks later is the typical time frame. It concerns me as an indicator that it might not tell us all we really need to know. And I like to see numbers on the soil test. The test to really have us give us a point of reference that we can start to look at what is actually happening. Now, on the left here, we see a no-till soil with very degraded cotton. So that indicates high biological activity. But for biology to operate at its best, it needs moisture, and it also needs nutrient other than the carbohydrate, the cotton that's in this fabric. So while this is telling us this soil here is not as active as this one, it may have been dry and it may not have had much nitrogen available, certainly that as a primary nutrient. And we would be looking at making sure that we understand really what's driving that biological activity. The conventional soil on the right would be indicating that it's not performing as well as the no-till soil. So that there's some other things in there that we'd like to know. So being cautious to understand indicators, and being cautious to, from my point of view certainly, is to get numbers with that test, so that you've got a base to work from. This is probably, you may consider it a shameless plug for a laboratory that I use called Microbiology Labs in South Australia. They are looking at combining the chemistry and biology analysis and giving growers some very good information around the biological function in soils. So we're looking at this test. It's called an NWISE for nitrogen, and it's measuring nitrogen fixation, nitrogen mineralization, the conversion of ammonium to nitrate. And when we're looking at a figure here of not measurable, we'd be looking to see other chemical parameters, physical parameters in that soil of why that might not be measurable. Now, in this case, we might find that soil is quite acidic and not converting from ammonium through to nitrate. So it may be indicating an acidic soil, not had much limestone, pH is quite low. So they'd be the sorts of indicators we'd be looking at with that test. Certainly for nitrogen, this is a very, very good test. It takes about 3 weeks to 4 weeks to run, because it's put the soil that's provided for analysis, put into a controlled environment where moisture and temperature is maintained. So we can actually see what that soil is doing over a period of time and correlate that back to how it might function on farm for growers. C-wise is obviously carbon-wise, and it's measuring the types of carbon form that are available to plants, in the soil. So their indications for soil health are around how quickly that carbon is degrading from a complex carbohydrate like a leaf or a piece of pruning wood through to soluble carbon forms that are the sugars and the food sources for bacteria and readily available to organisms to utilize. If a pruning twig is cut from a tree and it's not degrading quickly, we could be looking at that being a habitat for pathogen. So they're the types of things we'd be looking at reading into these soils analysis. We often see this small, quite flippant quote of a soil contains more microorganisms than people on the planet. What we do know nowadays, and with the type of testing that's available, we can tell how many microorganisms are actually there. We can tell the role and niche that they play and the habitat that they live in. We can measure pathogen levels now and make decisions around using different varieties of crop or changing the crop rotation. A little bit harder in trees, but we can do that with cover crop types to look at the reduction or understanding of pathogen. And we can also tell the interrelationship of groups of microorganisms in the sample, and that's how this next test that we'll look at is reported. So this is a test called MicrobeWise. So it's a measurement of these groups of functional organisms. So Pseudomonas, Actinomycetes are functional groups of microorganisms. We won't get bogged down in this. There's some pretty detailed and technical science in that. But these functional groups are being measured, and they provide roles in the soil to provide soil function. So we will touch on that in just a moment, but there's quite a range of analysis there. This is called a phospholipid fatty acid analysis. It's quite commonly available and very widely used as a soil health measure. What we prefer to be looking at with this test though is a soil function measure, and we'll just show those where each of these functions that we're looking at on the top of the little charts is really a combination of those functional groups of microorganisms that we looked at on the previous slide and the role in which they play in soil functioning. So there's a weighting there of a couple of different groups that they are combined to give us a rough score there of how that soil is functioning. That's a good broad baseline test for growers to utilize that can be used to measure over time changes in your management and improvement in soil function. The next test that we'll have a quick look at here, and it relates more to our erosion stability, and that's this test for soil structure as an indicator using glomalin. Glomalin is a protein primarily as a breakdown product of mycorrhizae in soil as they grow and die, and they leave this protein behind, and it is strongly correlated to aggregation in soil. So often referred to as a glue, it holds soil particles together. That test as a further indicator is water stable soil aggregates, where an aggregate from the soil is put into water and allowed to disintegrate or hold together, providing information around that stability. So that's a good test for people to be looking at, measuring a protein in the soil that contributes to soil aggregation. There's probably the second most important aspect of soil measurement is and constraint in soils, very closely following behind pH, is compaction. Compaction is a real curse in all agricultural systems. It restricts air movement, it restricts water movement, both in and out and down below as water drains in soils, restricts root growth, which limits moisture availability and nutrient availability. And it's a real issue in orchards where we've got a physical crop that we're having to drive between, and increasingly so where we're mechanizing with vehicles to harvest crops, driving throughout orchards and throughout the trees. They're quite restricted in the areas they can go, so they're covering the same ground all the time and spreading that or causing compaction throughout our farms, certainly in those heavier red soils and clay soil types up in the hills around in the northeast of Victoria. Management, of course, is traffic. Well, we just touched on that, how it's a bit challenging in terms of managing vehicles and harvesting equipment on larger orchards, but the control of that, if there's by different tyre types that can be fitted to equipment. Also, we can look at it with, also we can look at managing with nutrients. So managing salinity, which also degrades and contributes to compaction. We'll touch on that a little more in the second video. And calcium and magnesium are important tools to help, from a chemical nutrient point of view, help to try and manage compaction. Waterlogging, which we'll touch on again in the next video, also can contribute to erosion. So waterlogging creates a physical barrier for air movement, both gases from the roots escaping out of the soil and then fresh oxygen air moving into the soil. So that's an important aspect of aggregation, where waterlogging fills all those voids and restricts air movement. So understanding compaction and looking at methods in your soil type to reduce compaction or manage the buildup of compaction. Irrigation is important in managing waterlogging, certainly in the summer months, and that is another important aspect of disease management for diseases like Phytophthora. Understanding your soil, understanding where water is and how it sits there, and then improving your irrigation practice is a really strong tool to utilize for managing diseases like Phytophthora and some other soil-borne diseases. So just in respect of soil health, there are a broader range of tests that can measure functioning of the soil as it relates to acidity and erosion. I know I've only loosely touched on them presently, but I would encourage people to look at budgeting for soil analysis, a broader range than what you're probably doing now. There is a significant range of tests available, and looking to spend that money and ensure that you're getting good advice in managing the constraints that exist in your soils that you can measure. So thank you very much for this first video, and opportunities will come up at any time for you to be in contact and ask questions. And we're looking through 2021 through Chestnuts Australia, looking to still try and get some face-to-face meetings and be sharing this information in a little more detail and a little more specific to grower needs and grower questions.